In this unit, we'll be talking about rational expressions. Rational expressions and rational functions just are functions or expressions that deal with fractions. So we'll talk about reducing or simplifying, multiplying and dividing, adding and subtracting, and solving equations even that are rational. The first concept is that of the domain of the rational function. So what is the domain? If you remember back to functions, the domain was the x value. So when we're looking at the domain of a function, sometimes there are restrictions. We know that when we're dealing with fractions, the denominator cannot equal 0. So the restriction to this domain would be whatever value made our denominator 0. The numerator is not important. So all we're going to do is focus in on the denominator, since that's the only place where a restriction occurs. So we simply set the denominator to 0 so we can find out which x value or what x value or values plural would make our denominator 0. So now I'm going to solve for x. And x equals -5. So what does that mean? That means if we use -5, our denominator will become 0, which is undefined. So for our domain, we say we can use all real numbers except the one that makes our denominator 0, and that's -5. So again, the domain defines what values we can use for x. So we can use all real numbers in this case except for -5 because that makes our denominator 0. Our next concept is simplifying fractions or reducing fractions. So in this case, we have -21x cubed y squared over 15x to the 5th y to the 3rd. So what I'm going to do is separate this into parts. So I have -21 over 15, the x to the 3rd over x to the 5th, and y squared over y to the 3rd. So what we're going to do is reduce each one of these individually to get our final answer. There's a variety of ways to do it, but I want you to always look at problems logically. So in this case, what we're going to do is reduce the coefficients. So we have -21 and 15. The greatest common factor would be 3, so we divide 3 out of each one, and our denominator becomes 5, and our numerator becomes -7. So let's look at our variables. X to the 3rd over x to the 5th. So if you'll literally think, I have 3 x's in the numerator and 5 x's in the denominator. So I'll make that so you can see it. So whenever we're reducing, what we're doing is eliminating 1 for 1. And so what are we left with? 2 in the denominator. So wherever you have the most is where you'll have it in your final answer. So in other words, we had more x's in the denominator, so we know that our x will remain in the denominator, and we can simply subtract. 5 minus 3 is 2. So for our y variable, again, instead of having to write out y 2 times, y 3 times, and cancel 1 for 1, we compare. We have more y's in the denominator, so y is going to end up in the denominator, and all we're going to do is subtract. So we take 3 minus 2, and that gives us 1 left. So our final answer would be -7 over 5x squared y to the 1st, but we just leave it as y. The exponent is understood. So our next problem, we're also simplifying. Now, one thing I want you to keep in mind is that 4x squared plus 6x is a single factor. We cannot reduce these individually. So what we're doing is looking at a value that divides into both 6x squared and into 4x squared plus 6x. So what you want to do whenever you have a polynomial, something subtracted or added together, is factor. So here in the numerator, we have 6x squared. And in the denominator, we're going to factor out a 2x because that's our greatest common factor. So when we factor out the 2x, that leaves us a 2x plus 3. In other words, if I multiply 2x times 2x, I get 4x squared, and 2x times 3 would give me 6x. Okay, so now I reduce. So 2 and x are separate factors from 2x plus 3. So the only thing I can reduce a 2x plus 3 with is another 2x plus 3. There's not another 2x plus 3, so that's going to remain in my denominator. Now for the 6x squared and 2x, I'm going to do like I did in the previous example. So I'm looking for the greatest common factor of 2 and 6, and that's 2. So I'm going to reduce each by 2. So that leaves me 3 over 1. And with my variable, I have more x's in the numerator than I do in the denominator. So x will remain in the numerator. And I simply subtract. 2 minus 1 is 1. So my final answer is simply 3x. And you can leave this in parentheses if you'd like, over 2x plus 3. I would leave it in parentheses to remind you that 2x plus 3 belong together as a single factor and cannot be reduced individually. Next example. Again, keep in mind that since I'm adding and subtracting, these terms make up a single factor together. So I cannot reduce individually. So my first step is going to be to factor. So in the numerator, my greatest common factor is 3. And when I remove the 3, that leaves me 3 times the quantity x plus 3. In the denominator, it also has a common factor of 3. So when I remove the 3, that leaves me x squared minus 9. So anytime you're left with an x squared or an x cubed, that means you may, not for sure, but you may be able to go further. And if you notice what we have in the denominator, this is the difference of squares. So we can use our shortcut. So remember our shortcut. We know that x times x gives us x squared. 3 times 3 gives us 9, and one of them's a plus and one's a minus. And in my numerator, I have 3 times x plus 3. So what I want you to remember also is we're not canceling, we're reducing. So the common factor of 3 and 3 is 3. So when I reduce, that leaves me a 1. Same thing with the x plus 3 over the x plus 3. Those are common factors. So when they reduce, it becomes 1 because anything over itself, of course, is 1. So now in my final answer, I multiply straight across. So 1 times 1 is 1 in my numerator. And in my denominator, 1 times x minus 3 is x minus 3. Now let's talk about multiplication. When you're multiplying two fractions, you do not need a common denominator. Okay, so what we're going to deal with in multiplication and division is reducing exactly the same way as we just did the previous problems. So what we're going to do is keep in mind that when there's plus and minus signs, they belong together and we cannot reduce individually. The only thing we can reduce an x squared plus 3x plus 5 with in that state is another x squared plus 3x plus 5. Same thing with the 2x minus 8, and same thing with the x squared minus 9x plus 20. So this is why it was very important to learn the shortcut, because it's going to make the factoring part easier. So before I get into factoring, what I want to do is look at what I have in the problem. And the first thing you should notice is that in the numerator, I have x squared plus 3x plus 5, and I also have an x squared plus 3x plus 5 in the denominator. So I can reduce those right off the bat. So that's going to leave me, and we're going to do more with this, with a 2x minus 8 and the x squared minus 9x plus 20. So now in the numerator, I'm going to remove the greatest common factor, which is 2. And that's going to leave me 2 times x minus 4. In the denominator, we can use the shortcut because we have a 1 in front of our x squared. So we can go directly into the factoring. So we're looking the factors of positive 20 that would add to a negative 9. So we know negative 4 plus negative 5 is negative 9, and negative 4 times negative 5 is positive 20. So all we have to do is write in our minus 4 and minus 5. Our last step is to reduce. So both the numerator and denominator have factors of x minus 4. So in my numerator, I'm left with 2 times 1, which is 2, over 1 times x minus 5, which is simply x minus 5. So again, practice the shortcut. It's going to make these problems very easy, or I shouldn't say very easy, but simpler for you to reduce, and they'll take a lot less time. So let's look at another multiplication problem. So here I have x cubed minus 27. So I have a plus or minus separating. So I'm putting that in parentheses. Over x cubed y squared. There's no plus or minus, so I can reduce those individually. Times x y to the fourth. So that's x to the first, y to the fourth. And again, those I can reduce separately over x squared plus 3x plus 9. So that goes in parentheses. So our x cubed minus 27. So we have a cube. So we're going to have to factor using the difference of cubes. So I'm just going to remind you of the formula that you use. Because remember, this is a pattern. And we're going to use this pattern to factor. So the x cubed minus 27, I'm going to go ahead and factor that over here. So it's x cubed minus 27 is 3 cubed. So that's our a and b from like we did before. So then remember it's a minus b, so it's going to be x minus 3 times a times itself, so x times itself is x squared. Then we have a plus a times b would give us 3x plus b times itself, so 3 times 3 is 9. So the x cubed minus 27 factors to x minus 3 times x squared plus 3x plus 9. In my denominator, I have x cubed and y squared. In my numerator, I have x to the first and y to the fourth. And in my denominator, I have x squared plus 3x plus 9. So normally I would look to factor, but again, being observant, you'll see that the x squared plus 3x plus 9 occurs in both the numerator and the denominator, so I can reduce. So now when I'm looking at other factors, the x minus 3 in the numerator cannot be reduced. I'm comparing my x cubed and x to the first. I have more x's in the denominator, so it's going to go in the denominator. And when I subtract 3 minus 1, that means I have 2 left in the denominator. And for my y's, I have more y's in the numerator than I do in the denominator. So y is going to remain in the numerator, and I subtract 4 minus 2, and that gives me 2. So you can write your answer that way, or you could move the y squared up front. Either way, the answer would be correct. So division, what are the rules of division? Well, they have the exact same rules as multiplication. So in division, the only difference is, remember that when you divided fractions, you changed it from division to multiplication and you took the reciprocal of the divisor. So the first thing that we're going to do is take the reciprocal of the divisor and change it to a multiplication problem. So this becomes x squared minus 5x plus 6 over 3x squared minus 8x plus 4 times, now I'm going to flip the 2 over, 15x minus 10 over 25x minus 15. So all I've done is taken the reciprocal of my divisor. Your divisor comes after the division symbol, and I changed it to a multiplication problem. So now I need to factor. So in my numerator, the x squared minus 5x plus 6, I can use the shortcut. So I'm looking for the factors of positive 6 that add to a negative 5. So that'd be a negative 2 and a negative 3. So I get x minus 2 times x minus 3. I'm going to factor the 3x squared minus 8x plus 4 in a second. So now for my other numerator, 15x minus 10, I'm going to remove the greatest common factor, which is 5, and that would leave me with a 3x minus 2. And then I'm going to factor the 25x minus 15. That also has a common factor of 5. When I factor out a 5, that leaves me 5x minus 3. Okay, so now I have to factor the 3x squared minus 8x plus 4. So the first step in all factoring is to remove the greatest common factor. Nothing divides into all 3, so now I use the AC method. So I'm multiplying my 3 times my positive 4. That gives me a positive 12. So remember, I'm looking for the factors of a positive 12 that add to a negative 8. So that would be a minus 2 and a minus 6. So I'm going to rewrite this as 3x squared minus 2x minus 6x plus 4, then factor by grouping. So in the first group, the common factor is x, and that would leave me a 3x minus 2. Remember, in my second group, if that's a negative, I'm going to factor out a negative, and 2 goes into both. Keep in mind again, because a lot of students make mistakes here with the signs, I'm factoring out a negative 2. So negative 6 divided by negative 2 is positive 3, and positive 4 divided by negative 2 is negative 2. And again, my greatest common factor, 3x minus 2, and the values on the outside make up my other factor. So 3x squared minus 8x plus 4 would factor to 3x minus 2 and x minus 2. Now I can reduce. So here I have an x minus 2 and an x minus 2, a 3x minus 2 and a 3x minus 2, a 5 over 5. So in the numerator, I'm left with an x minus 3. And in the denominator, I'm left with a 5x minus 3. Again, when you look at it inside parentheses, they're not the same, so I can't reduce these any further.